In this video, we're going to look at buffers, and we're going to kind of describe what is necessary to make a buffer, and also how to calculate the pH of a buffer. So the definition of a buffer is it's a solution that can resist changes in pH. When small amounts of acid or base are added. And I think small amounts is the operational phrase here. So no buffer is going to resist large amounts of acids or bases, but most buffers will resist very small amounts of dilute acids or tiny amounts of strong acids. It turns out there's always two components you need for a buffer. And the two ways you make a buffer are you need to start with a weak acid and its conjugate base. Okay? Or you need to start with a weak base and its conjugate acid. And in some way, you really just have a conjugate acid-base pair. It just has to be for a weak acid or a weak base. So, for example, if you want to pick on a weak acid, acetic acid is an excellent one to start with. So acetic acid is HC2H3O2. And so by itself, it wouldn't be a buffer. So if you had a solution that contained both acetic acid and its conjugate base, so remember, we just have to tear off a proton. And when we tear off a proton, we're left with a conjugate base. So that would be acetic acid, and this would be the acetate ion. So that would be a buffer. Another buffer would be if we had a weak base. So for instance, something like ammonia and its conjugate acid. So we just add a proton. So we push on a proton. So that would be NH4+. So that is the ammonium ion. So if you had both of these in solution, you would have yourself a buffer. Now, the only thing is, if you go into the stockroom, you can certainly find bottles of acetic acid, but you can't find bottles of acetate. So you have to find a ionic compound that contains acetate. And so you would need to have something like, say, sodium acetate. So I'm going to go ahead and write the charges in, which is a little bit naughty. Probably shouldn't, but sodium acetate would be a very good one. And why would you use something like sodium acetate? Well, in the last section we looked at, the sodium ion is actually neutral, so it comes from a strong base. We could have used lithium, things like potassium or strontium or magnesium or all sorts of things like this. Sodium salts tend to be relatively cheap though, so we have to have a counter ion to counteract the charge on the acetate. And the same with ammonium on the right hand side. We can't find ammonium in the stockroom, but we can certainly find ammonium solutions, and so, or ammonium compounds. So if we paired it up with something like chloride, which is a neutral anion, so ammonium chloride would be excellent, or ammonium bromide or ammonium iodide, or any other counter ion that comes from a strong monoprotic acid. Ammonium nitrate would also be excellent. So these would give you buffer solutions if you combined these two things together. All right, let's see if you can recognize which one of these pairs would be a buffer. So I'll give you three different pairs of compounds. So HCl, NaCl, and something like HF, KF, and maybe something like HNO3, LiNO2. So out of these three, which one or ones would actually be a buffer and which ones would not? So pause the video, see if you can figure out, and then we'll compare notes. All right, so if you've unpaused, so HCl is a strong acid, and so definitely it's not going to work. Even though NaCl is the conjugate base, HCl is a strong acid, not going to act as a buffer. HF is a weak acid, and because we need the conjugate base, we remove a proton, so that is F-. Now you can see KF is not just F-, but we have to have a K because we have to counteract the charge on F-. So that would be K plus F-. So yep, that would be a buffer. And the last one is HNO3, LiNO2. Well, HNO3 is actually a strong acid, so that would not work. And LiNO2 is actually not the conjugate base of that strong acid. Now, if we use something like HNO2, which is a weak acid, and the conjugate base, which is nitrite, so LiNO2, that would work because lithium is a neutral ion, so that wouldn't actually be a buffer.